All right, moving on. Let's take a look at this next problem here as we're looking at finding slope. It says find the slope of the line that goes through the following pair of points. So remember, slope is your direction of your line. All right, so it's the rise and the run between any 2 points on a line. So let's go ahead and write our definition up here. So in math, we denote slope with m. So again, m is your rise and your run between any 2 points on a line, which is your change in your y values, right? Your rise factor is how far up or down you moved to get from point 1 to point 2, which would be the change in the y values. And then the run factor is how far right or left you go, which would be the change in the x values, right? So change in y over change in x, which is your vertical distance and your horizontal distance, defines your rise and run. So if you've got 2 points on a line, you take the 2 y coordinates, find their difference. That's your rise factor. So say we had points 1 and 2, we'll label the y coordinates y2 and y1. So the difference in those y coordinates divided by the change in the x coordinates of those 2 points. So x2 minus x1. So that's our slope definition and formula. So as you look at example A here, so what I'd like to do first is go ahead and just look at this one together. Let's just draw a quick picture of this line that they give us. So 4, -7, right 4, down 7 units. So somewhere down here in quad 4 would be that ordered pair 4, -7. And then right 9, up 5, be somewhere up here in quadrant 1. I'll plot that point. As you can see, as I'm drawing this line, we've got an increasing line. Right, it's a line that's going up from left to right as x is getting larger. Y is getting larger. So as x is increasing in value, y is increasing in value. And now that implies our slope, m, is going to be positive. So if slope is positive, we have an increasing line. If slope is negative, we have a decreasing line. If there's no slope, we have a horizontal line. So slope is 0, no rise factor, just going left and right. It would be a slope of 0. And then vertical lines is undefined. Because on vertical line, you have no run factor, which means the change in the x values would be 0, and you can't divide by 0. Right, that's undefined. So as you can see, we've got a picture of it. So as I'm looking at traveling from 4, -7, we'll call that point 1 here, over to 9, 5, the second point we're given, we can look at that and see, right, our rise and our run together. So we've gone up, let's take a look here. We've gone from -7 on the y-axis all the way up to 5 on the y-axis. So we've gone up, 12 units, right? Up 7 units, we'll be at 0, another 5, we're at 5 on the y-axis. So again, this vertical distance, right, this change in y value, this is up 12. And our run factor, how far right or left we moved, well, we can look at the x-axis. Where have we moved? Well, we've gone from 4 on the x-axis over here to 9 on the x-axis. So we've gone a distance of 5 units to the right? That's our horizontal distance. So that would be our run factor. So just looking at it, right, I know my slope, right? We've gone up 12 units, right? My rise over my run, right? Up 12, right 5, right? So there's our slope. Now that's just using the definition. Now again, with our formula, I'll show it too with the formula here. So m, remember, is equal to y2 minus y1 over x2 minus x1. So we can label these points, x1 and y1, and x2 and y2. And again, we can go subtract. So for example, the difference in the y coordinates, 5 minus -7, divided by the change in the x coordinates, 9 minus 4. And as we simplify, we know 2 negatives make a positive. There's that 12. 9 minus 4 is 5. So you can see, again, your slope using the formula. So yeah, in A, m is equal to 12/5, positive slope, increasing line. So again, you could plot the 2 points, graph it, and you will know again your slope value before you even begin. Let's go ahead and do the same thing. Let's find the slope here of example B here in problem that we have. Now I'm going to go ahead and label them, point 1 and point 2. So x1, y1, x2, y2. And as I go to my slope, so rise over run, y2 minus y1 over x2 minus x1. That's -3 minus -24 divided by 2 minus -4. Well, as I simplify, two negatives make a positive. So I've got -3 plus 24, which is what, 21, divided by 2 minus -4, that's 2 plus 4, which is 6. So I've got a slope of 21/6, right, on that one. So a change in y, right, over my change in x. So there's my value of m, which again, another increasing line, right, positive slope, increases. Now, before we go any further, let's go ahead and reduce that. So yeah, we should reduce, right, our slope. So we've got 21/6, so it does have a common factor. Let's go ahead and divide that common factor out. We'll go ahead and reduce that down. So as we divide out the common factor of 3, right, what does this reduce to? All right, let's go ahead and show our work here. Well, as we divide out the common factor of 3, we got 7 over 2 at 7/2. So yeah, reducing the slope, which we should always reduce, right? There's our slope, m. So again, a increasing line. Go ahead and make that note. And what does that tell us? That tells us our slope is 7/2. We're going up 7, right 2, up 7, right 2, right from point to point. There's your rate of change, right? Your slope of this line. Going to example C, let's go ahead and find the slope together, and we'll go ahead and just plug it right into our formula. So m, rise over run, y2 minus y1 over x2 minus x1. So -7 minus -3 divided by 7 minus -9. And as we simplify, -7 minus -3 simplifies to -7 plus 3, which is -4. And we know with 7 minus -9, well, two negatives make a positive. That becomes, what, 16. So we got 16 in the denominator. And let's go ahead and reduce. So as we reduce that, we have a common factor of 4. Let's go ahead and divide that out on both. So as we divide out, we got -1/4, right? So reducing that slope value. And remember, this is our direction of the line. So this is our first negative slope that we found. And that says down 1, right 4, down 1, right 4. So again, you would see that if you were to graph this line, it is a decreasing line. It's going down as you move from left to right. So again, that's our slope of the line. Let's take a look at example D. I want you to notice what happens with this one. As we find our slope, change in y over change in x, a rise over our run. We've got, what, -3 minus 5 as we subtract the y coordinates, divided by the change in the x coordinates, 2 minus 2. And notice what our denominator is, 0. Well, we can't divide by 0, right? We are undefined with this slope. So that means if we're undefined with the slope, that implies we have a line that is vertical. And yeah, if you'd have plot these 2 points, right, 2, 5, and 2, -3, right, and we could go ahead and look at it right here beneath it. I'll draw in quickly a x and y axis just to show what we found here. Right 2 up 5, here's 2, 5, and right 2 down 3. Down here would be 2, -3, right? There's no change in x. Right, there's a vertical line equation. So yeah, if the change in x is 0, we're going to be undefined, which means our line's going up and down, right? All we have is a change in y values. But again, no run factor in a vertical. We just have a rise factor. Looking at our last example, let's go ahead and finish this set out. let's see what our slope is here. So y2 minus y1 over x2 minus x1. So look at our change in y over change in x. Find our direction of this line. We got -6 minus -6 here in the numerator, divided by 1 minus -8 down here in the denominator. And as we simplify down, of course, two negatives make a positive. -6 plus 6 is 0. And here we got our 1 minus -8. Well, that makes a 1 plus 8 or 9. 0 divided by 9 is 0. So our slope is 0. Well, if our slope is 0, we have a horizontal line. So you've now seen an example of each type, right? Increasing line, decreasing line, vertical line, horizontal line. Yeah, if we were to plot these 2 points, right, as we look at these 2 points together, -8, -6, down here, -8, -6, down here in quad 3, 1, -6, down here in quad 4. Well, yeah, we graph this line. You see, again, there's a graph of that horizontal line there. Yeah, there's no, change in y values. The y value is the same. Y is constant. And again, this is an equation of the form y equal -6. We'll talk about the equation form. And back on our vertical line, x was constant. X was constant at 2. We'll talk about its equation. So that's slope. So we're going to carry that over into our functions as we look at the average rate of change. But we'll stop there with that. We'll continue on in a little bit.